Yep. So, adding vectors by scale at any angle. Yesterday, I showed you how to add vectors when they are perpendicular to each other. And the question just was, what does perpendicular mean? Perpendicular means when it is a, whoopsie, when it's a right angle, right? 90 degrees, like north and west, or south and east, right? Exactly perpendicular to each other. Okay, that's how we did it. When you do it, when they're perpendicular, you use Pythagoras. A squared equals b squared plus c squared, right? Opposite over adjacent, second function tan, all that good stuff. You can only use Pythagoras when the vectors are perpendicular to each other. So when they're at any angle, you can't. Vectors that are not perpendicular must be added by using scale diagrams. I'm going to highlight that. I'm going to underline it. I'm going to put a star beside it. This is the number one reason. If you're playing Family Feud and the question was reasons why students fail the first test, the number one reason, survey says, they do this wrong.
Maybe said that on Family Feud, they'd be like, they do this wrong. Probably.
They add vectors that are not perpendicular to each other using Pythagoras. That's way too long to put on the little ding, ding, ding board. Okay? I'm telling you, there's at least 4 or 5 of you that are going to do this wrong in the test. And this is what you're going to get from me. You're going to get a frowning. Okay? You can only use Pythagoras when they are right angles, perpendicular to each other. If it looks kind of like that, you cannot use Pythagoras. I'm yelling. You know what else I'm going to do? I'm gonna do this so that you guys understand. Oh, I can't do it. I was gonna change it all to all caps. I don't know how to do that. I ain't doing that. It's too much work. I'll just yell instead. You can't do it. You can't add them by Pythagoras when they're not perpendicular to each other. How many times have I repeated myself? To the point where you're like, shut up, man, I get it. But yet, at least 4 or 5 of you are going to do it wrong.
I'm glad you brought it up.
So how do we do it then, Mr. Bennett? Oh, wise man. You have to use a ruler and a protractor. Cole, are you listening? Because you might make that mistake. And if you're not listening today, you're going to get a double frowny face. Yeah. I don't know what it looks like, but you're going to get it. Add the following vectors: 10 kilometers at north 30 east and 8 kilometers at west 15 north. And the people that have been paying attention are already getting their ruler and protractor out. Well, I'm going to do it. I'm going to do it as an example. So the first step is to decide on a scale. We got 10 kilometers, we got 8 kilometers. We could probably go 1 centimeter equals, no, not 1. 1 centimeter equals, oh yeah, no, 1 centimeter equals 1 kilometer. That's what I missed. Okay. You must start your scale with 1 centimeter equals. Remember me saying that too? That's another common mistake. Half mark off on the test, guaranteed. Do it right. If it says 1 centimeter equals, do it right. 1 centimeter equals. Okay, so now we're going north 30 east. Now I'm going to need a ruler and a protractor too. There's my ruler. There's my protractor. Okay, first thing you want to do, now actually, the first thing you want to do is sort of think this through ahead of time. Because what quite often happens is people start in the wrong place on their paper. So if I'm going north 30 east, draw a little sketch. So I'm going to go north 30 east, I'm going to go like that. And then I'm going west 15 north. So I'm going west and then 15 north. So it's going to kind of look like that, right? So should I start way up here in the left-hand corner? No, I'm going to have to start farther down here. Okay, and I will try to provide you with plenty of space. So I'm going to draw my north reference line, just like that. And I'm going to go north 30 east. So I'm going to take my protractor, and I put 0 at north. This is a common question I get. So I'm going to put 0 at north, and I'm going east, right? So, and it goes at the bottom of the reference line, like so. And then I make a mark at 30 degrees east. North 30 east is going to be right there. Right? And then I'm going 10 kilometers. Get rid of the protractor. Come on. You guys actually have it a whole lot easier than me. Yeah, you do. It's hard to move these guys around. Come on, get on there. And I'm going to go 10 kilometers, so that's 10 centimeters. Okay. I need everyone to put their pens down and watch, because this next part is crucial. Okay? Now, I drew that line, I drew that vector. I recommend don't put the arrowhead on until the end, because it can get a little confusing, a little bit crowded. Okay? So draw it to there. Now, from here, I have to go west 15 north. You really should, and I have it easier here because I can sort of lock my protractor, right? So west 15 north, I have to put it perfectly flat, right? You really should draw a reference line there as well, showing west, right? A little tiny one. And I'm going to put my protractor down there, right there again, right where I ended. And now I'm going to go 15 north. 15 right there. Right? Everybody with me? And now I got to go 8 kilometers, so get rid of the protractor. And I'm going to go 8. So put my ruler here. And I'm going to rotate it. And I got to get it down there to 30. Okay, and I'm going to go 88 kilometers or 8 centimeters. To there. Oops, I went a smidge too far. What's the rule? How far out can you be? 3 millimeters either way, and it tends to always go a little bit over here when I'm doing this, so I just got to smidge that back a bit. Like that. Okay. Now you might want to put your arrowheads on. Okay, you should maybe label them. That helps me when I'm looking at it, trying to determine whether you know what you're doing or not. If they're not labeled, if you get them wrong, then I can at least look at it and say, okay, well, that's what they tried to draw there, and then I can make a judgment to whether I should give you a mark or not. Okay, now how do I find the result? Well, you're going to actually draw a line from there to there. Right? I'm going to make this. Okay, you're going to draw, and here's the part, here's the real, this is another common mistake. Draw from where you start to where you end, put an arrowhead on it, and label it. That's your resultant. Alrighty, what's the next step? Say again, George? You're probably right, go ahead. You have to actually use your ruler and measure it, right? You gotta measure it. You can't use Pythagoras. Why not? Not a right triangle. Exactly. So you're going to put your ruler on there and you're going to actually measure. You're going to measure. I don't know, I haven't got it on there. It takes me a while to get there. That just wants to rotate all the time on me. I get about 11.2. 11.2 centimeters. Now, no. I know a mathematical way to come up with the correct answer, the absolute perfect answer, and that's where I go my plus or minus 3. Okay? So all I've done there is measure the length of that line. It's 11.2 centimeters, which means that it's 11.2 kilometers, right?
11.2.
I don't know, 6.1? No, it's 5.5, 5.7. I measured that with a ruler and not a very good one, right? So, I mean, in this case, you're probably plus or minus 5 millimeters, because mine isn't exact. Okay? Now, everyone's got to look up here. Pay attention. This is the number one mistake that happens next. When you measure, what angle are you measuring? The resultant. You don't measure, you don't measure this angle here. Hang on. This is what you do not do. I see this all the time. They put 0 there at that one, and they measure, and they say it's like 42. They measure from the first vector. That is wrong. No, no, no. You must measure from your initial reference line. Because it says north, right? You can't measure from north 30 east. You measure from north, right? You always measure from north or south or east or west. Always. I see this all the time. So this angle here is actually, it's going to be like 15 degrees, right? So that's going to be north, 15 west. Okay? Now when I mark these, I usually give 1 mark for the angle, 1 mark for the length, and 1 mark for the picture, and probably 1 mark for the scale. Sometimes I have to sort of do a holistic kind of judgment. If you make a whole bunch of crazy mistakes and I'm not going to give you 0, I have to sort of figure out how much you know. Okay? So you got to draw them tip to tail. You got to do them to scale. You got to measure the right angle. You got to measure the right length. And oh my goodness. You don't want this. How do you get the frowny face? By use Pythagoras or tan. Sometimes I see they measure this, but then they give me the tangent. They go 8 over 10. No, it's not a right triangle. When you do it this way, get the smiley face. That's the one you want. Why don't you try this one? I'll give you more time to try. You're going to have plenty of time to practice. Don't worry. Okay, so let's pick our scale. This time it's in kilometers per hour. Now here's another common mistake. People write 1 centimeter equals, I'm going to go with 10, and they go 10 kilometers.
Per hour.
It's not 10 kilometers. It's 10 kilometers per hour. And you might say, well, how can a distance unit be a velocity unit? It's just a scale drawing. Okay, it can be. That's the way it's supposed to be. 1 centimeter equals 10 kilometers per hour. Now again, I suggest draw a little sketch so you know where to start, right? South 40 east is going to be, south 40 east is like that, and then east 75 north is going to be like that. So I should probably start like somewhere up here. They might have analog ones too, right? Like where it just gives you a reading, like not a digital reading, but like a, I don't know. Anyways. Okay, so 1 centimeter equals 10 kilometers per hour. We're going south 40 east. So draw the reference line south. Lots of people say to me, how long should the reference line be? Doesn't matter. Centimeters good, doesn't matter, right? Because I'm going south, here's Leo's question. I'm going to start from the north. Because I'm looking south, right? So I'm going to start at the north end, and I'm going 40 east.
Wait, so you start from the bottom?
No, the top.
Oh my God.
Okay, so from the top, looking South, I'm going to go 40 east. 40 east is going to be 0, 10, 20, 30, 40 east right there. Right?
Is there a way to do this without drawing it? Like, can you just do the math on this?
In grade 12 you can. Yeah. Do it this way. It helps you understand, helps you visualize, it helps you see everything. Which is why I do it this way in grade 11. Okay, so I'm going 10 kilometers an hour. It's 80. So Sarah, how long should it be? 8. Oh, and I've got, so that's going to be 50. I got a little protractor on there that helps me get it lined up. Okay, get in there. Okay, and I'm going 8, right? I went a little past. Okay, don't put the arrowhead on till you're done. Okay, then from there we're going east 75 north. So bring in your protractor again. You guys should probably draw a reference line showing east. Get over there. Come on. Okay, so from there I look east and I'm going 75 north. 75. So east 75 is there. And I'm going to go 35, which would be 3.5, right? Got to go this. Five. Does take me a little while to get things all lined up. And I'm only going 3.5 centimeters to there. Okay, drawing your arrowheads. Where do I draw my resultant from? From where you start to where you end, right? Oh, I shouldn't have done it in red. And I'm going this way. And how long is it? Well, that's inches. I got about, 6.8, 6.7, something like that. If you're close, you guys, I'm going to get a ruler and I'm going to look. Yeah, I got 6.8. As long as you're within, and again, I have the exact answer on my answer key. It's a whole lot easier for me to do it with a paper rule. It's hard up here because it sort of goes from pixel to pixel. So 6.8 would be 68 kilometers per hour, right? And then you're going to put your protractor up there.
It even says north right there. Yeah, okay, but it's 75, it's east.
You got to measure from the reference angle, the reference line. So that's south, and then we're going all the way over here. That's going to be like 66 degrees. So that would be south, 66 east. There's your answer. From here, from south, that's 0, right? And you're going way up to there, 66 degrees.
Oh, you can't do like east 25 south?
You could. You want to go from, the only thing is you've already got south, you've got that reference line there, right?
On like that, and then I like used the line coming out from the east and went down from there.
Yeah. If you want, you can measure from east. The only thing is you don't really have a reference line. I guess you could put your sure. Yeah, so that would be east 24 south, right? Either one is fine.
One was like 6.6. I got 65. Like the big
That's fine, Cody.
one.
Yeah. Oh, just 2 practice ones? Is that all?